I think we've had a great lineup of speakers and really appreciate everybody throwing in their comments tonight. I think the thing that struck me most so far is that data and agentic are keys to the deployment and use of AI in our enterprises today. And historically, what we've seen in the adoption and diffusion of innovation and technology in the enterprise is it's been largely driven by platforms. It was the operating system platform, the mobile platform, the cloud platforms, and now we're in this generative AI era. We need AI platforms. We need platforms that take the complexity, the difficulty of managing all those components, your data mesh architecture, your agent registries, your security and compliance concerns, and hide that complexity. And this is the key to solving for that generative AI era that we're entering today, is to build platforms that hide that technology, hide that complexity, and enable us to deploy and manage AI at scale, scaling it out, scaling up. And today I'm going to outline some of the key strategies that we're going to use in order to implement these platforms for the future and bring this AI into the enterprise. So this is three major categories. And I'm going to hopefully leave you with these three things, and this is all I want you to remember today. Tame the beast, right? AI and LLMs are notoriously big and heavy. Everyone here has probably now heard about all the controversies about AI data centers, power, the cost of electricity, the availability of GPUs, right? This is creating friction and resistance to the adoption and diffusion of AI systems. So we need to tame that beast, take these giant LLMs and make them easy to use and manageable, and deploy these into our enterprise that we already have and that exists today. The other one is spreading the work around. And you're going to hear a lot more. I looked at the agenda. Agentic architectures are coming, and they're coming fast. Right? We need to spread the work of our AI systems across our existing enterprise, using the tools that we already have available at our disposal, and to get access to the data that unlocks the power of our enterprises, powers our AI systems, and lets us make business-critical and value-added decisions. And then finally, I call this master the mind. Right? Our AI systems are getting increasingly complicated. We are driving our AI systems using our context and using information that's in our enterprises. And we have to understand how these AI models work, how to control that context, how to make and use the systems that we have in place to drive these agentic architectures and do it safely and without leaking our data or risking our mission-critical systems. All right, so if we look at like taming the beast, right, and especially this is critical and going to be critical in the agentic era, right, where we're talking about deploying lots of different models, recycling and reusing those models constantly in different contexts and for different purposes, and accessing different data. So we're going to need to optimize how we deploy those models. So model and agent optimization in the deployment and running and serving of these models is going to be absolutely critical. I was reminded by one of my guests today that when I was sitting next to talking, fundamentally AI and generative AI in particular is math. It's all math under the hood. And what we need are tools and techniques that use and leverage that math to optimize those models and that model serving so we can deploy at scale and manage the life cycle of our models and serve those effectively. The other thing we need to do is get away from this GPU-centric architecture. Don't get me wrong, I love NVIDIA, I love GPUs, but CPUs are everywhere. We have a ton of CPUs, and we can't deploy a GPU everywhere we might want to run a model, right? GPUs are expensive, they use a lot of power, and the fact is, like at Edge or in other places where we want to deploy some of these models, we just don't have GPUs. So we need to take those same tools, those optimization tools, and apply those to CPU-based deployments and CPU-based inferencing. So we can take our AI, deploy it where we need to, and use those AI models where we need them. The last thing is that we're also entering, especially with the rise of agentic architectures, specialized models, right? We no longer just throw every problem at a large language model and hope for the best. We are now building and training specialized models that handle specific tasks, right? This is the heart of agentic architectures. But in order to use these effectively, we need orchestration between these models. Tools that can determine autonomously which model will most effectively service a request or service an inference request, and direct our AI and our usage to that specific model. So we can introduce semantic routing into our AI infrastructures to use AI as a tool to direct those requests to the most appropriate resource, the most efficient and the resources and the models that can service those resources. All right, next is spreading the work. All right, we have widely distributed enterprises, and we need AI architectures that match that distribution and spread that work across our enterprises. So agentic architectures, again, the reason why agentic is so hot is because it matches our existing enterprises, right? We can take the work and spread it around. But in order to do that and to do that safely, we need guardrails around our AI models and around our agents. Things will automatically manage the context, that will manage the security, create observability so that we can watch and monitor what our AI and agents are doing throughout our enterprises, and lifecycle things. So when we update our models or update our agents, those get updated as well. The other thing that we need is to do this efficiently, right? So these three themes are really tied together, right? And this is through distributed interface. Like I said, we have widely distributed enterprises, and we need to distribute our inference just as widely. But to do that, we have to create tailored models for that. AI inference is not the same thing as managing web requests. But we've spent 30 or 40 years building our enterprises around a model of enterprise IT that is designed to service cheap, relatively uniform requests, but that's not the model that AI uses. Those requests are expensive. We have context to worry about that we can't afford to spill across those requests. And every time we spin up a model or an agent, right, that agent is spinning up or populating from its cache or its context data, and we can't just willy-nilly throw requests at any old model. We need to dynamically route and distribute those requests to the model in the instance that's most appropriate for that, as well as be able to scale those model servers up as necessary to handle burst loads or scale those down to save money on those models so they're not just sitting there idle. The last thing in spreading the work is what is called federated learning. And I'll apologize for the cut and paste here on the text there, but the model of federated learning is this idea of training your models or tuning your models where your data is. Instead of bringing your data to a central location, you can actually distribute the training to remote coordinator nodes or contributor nodes managed by a coordinator that applies governance and security policies, take those partial model results during training and recombine those. And this lets you move your training or move your tuning to where your data is. Keep your data safe and secure in those and protected by your existing security controls, but still leverage AI to exploit that data. All right, last thing is mastering the mind. All right, context and MCP is absolutely critical here, and we're again going to hear a lot about agents and how this works in this context or in this area. But the fact is that AI models are driven by context. Fortunately, agentic architectures help us build specialized models and specialized tools that need smaller context, and now it's a matter of orchestrating across that context. But managing that context, managing the context windows, and sharing context between these agents is going to be how we scale these architectures and implement this orchestration across these different models. All right, the last couple here, RAG. Everyone here has probably already heard of RAG, and this is absolutely a critical strategy to scaling up. Because RAG lets us take existing models instead of retraining or retuning these models, using a lot of those resources to do that. We can use existing models without having to tune those and exploit our data. So RAG is already a well-worn pattern, and we just need to scale that up. And last, in order for all these tools and these techniques to be effective, we need trust and explainability. Agentic architectures and this orchestration at the top is going to allow us to inject into our agentic architectures the appropriate guardrails, the appropriate monitoring of our models so that we can observe those, take corrective action to redeploy those models when necessary. And last, all these techniques, in order to realize these, we're going to have to build these into a platform so we can make those easy to deploy, scale up, without having to reinvent our IT systems. Thanks very much.